let's start with the FireNet, the firewall network. So far we have discussed a lot of things about the public cloud and the cloud networking, right? And then we talked about the importance of MCNA. We talked about transit. These are important topics for the exam as well. So I'm just giving you some hints here, okay? Then we talked about the high performance encryption, ingress security, egress security, all those features that Tomas was explaining to you. Now, this firewall network and why actually we came up with this solution to solve the problem in this space. So what happens that as soon as you start onboarding any meaningful workload in the cloud, any production workload or anything that is touching the production data, you hit by this requirement from your InfoSec or from your compliance team that, hey, dude, this is important data, could be HIPAA medical data or PCI data. You need to make sure that you are inspecting the traffic going into this workload or leaving from this workload. And it has to be inspected at layer 7 level, right? So you should use something like next generation firewall to inspect that data deeply. Those constructs that we discussed, like the layer 4 security groups, stateful firewall, those are not enough. Yeah, those are important, but not enough to comply or to pass the audit, right? So there is a need to inspect this traffic. Okay, so we all know that. Now this traffic could be east-west or could be north-south. Now it's important to understand the definition of east-west because in the on-prem, the east-west was within your data center, and north-south was anything that was going out, right? Here, the east-west is VPC to VPC traffic and VPC to on-prem because on-prem is still part of your data center if you're still running the on-prem data center, right? So that's east-west. And north-south is anything that is going towards the internet or coming from the internet. So you need to make sure you're protecting all these traffic and traffic flows. So the solution that we have allows you to apply this firewall in any scenario that you can imagine, right? So the diagram that you see here is a diagram where I have a VPC in AWS, some GCP, and then some Azure workload, right? So the solution allows you to inspect the traffic if it is happening or going between VPCs inside a cloud, right? Okay, let me annotate so that you guys can follow me. Okay. And if your traffic is going towards the internet, obviously it has to be inspected by the firewall. If you have traffic coming in from the data center, it needs inspection, then it has to go through this firewall network. Any branch that you are connecting to the cloud, any partner site, it has to be inspected. And if you are sending the traffic towards another cloud, the requirement remains the same, right? Because at the end of the day, that's an important data. Now, the Aviatrix controller and this platform that we have allows you to achieve all these requirements using just single FireNet solution that we have. And I'll tell you in coming slide how we have designed this and the problems that we are solving for a lot of customers. So when you look at the existing problems in the cloud, and if you start to inspect this data, you notice that the solutions that are out there are not complete. They have their inherent limitations and their challenges. Some of them are actually coming from the firewall vendors because these firewall vendors, they have uplifted their hardware appliances into the cloud. And they give you this firewall and they say, you know what, you need to figure out everything else. Obviously, you need to figure out how to route the traffic towards this firewall, how to receive the traffic back from the firewall, send it to the destination. And also in the process, you need to make sure there is no asymmetric routing happening, right? Because if it happens, then the firewall will have no knowledge about the flow and it will drop the packet, right? So there is a lack of understanding of cloud native networking that is, these firewall vendors that they don't actually provide you. So their job is to just to provide you this firewall. And in some cases, I have also seen that because of those limitations in the firewall in the cloud, customers end up hairpinning the traffic towards the physical firewall on-prem. And that's not the right solution because you're wasting the bandwidth, you're wasting the licenses on your firewall also, right? So that's not a good solution. These cloud providers, in majority of the cases, they don't have their layer 7 firewall. And if they do, those are not at a feature set which you would need for your enterprise. Okay, so you're basically stuck. Like, okay, what should I do here, right? And then you have to figure out all the routing yourself, and you have to manage it also, right? So yeah, you deploy a firewall once, but that's not a one-time deal. You have VPCs coming in, you have more workload coming in. You might have a branch coming up in a month or so, right? So then you have to figure out the routing again. So it's a painful job, right? So customers are, they are deploying their scripts. They are using some Lambda script or something to make sure all these use cases are covered and they are actually in compliance. So let's take a look at the native solutions provided by these firewall vendors, and then we'll talk about what Aviatrix is solving or doing in this space to solve those challenges. So let's take a look at Azure. So if you look at Azure, Azure have a native firewall, right? So in the diagram, you see this is your Azure firewall, right? So it's natively available by Azure, and you can deploy it in active fashion. But the problem is that when you want to send this traffic from, let's say, this spoke VNET to spoke VNET number 2, you need to make sure that you have all the UDR done properly. You point it to the VIP of the load balancer, and then it goes to the firewall, and then to the destination. But if you're running it in active mode, then you have to deploy the SNAT or configure SNAT so that the return traffic should go here, right? And it's not hitting this firewall, for example. Otherwise, it will break the traffic. So these are the problems we see. But the good thing about at least this Azure firewall is that it can give you the SNAT automatically, so you don't have to configure it. But on the other side, if you look at the third-party solutions, for example, if it is a Palo Alto VM or any third-party VM, and if you want to deploy it in active fashion, basically the challenges are same, right? You have the long and inconsistent failover NHA. You are configuring or deploying some script to make sure your HA is working properly. When it comes to managing it, again, it's a pain to program all these routes, the UDRs into the system, right? It's just a very high complexity, high management that you need to do for the Azure. And SNAT is not done automatically. So you have to configure SNAT if you want to deploy these firewalls in active fashion. Okay, so that was Azure. Let's talk about AWS, what native solutions they have. So in case of Azure, they don't have their layer 7 firewall. So they are heavily dependent on the third-party vendors, for example, Palo Alto, Checkpoint, or Fortinet. So again, when you are about to deploy this firewall in AWS, okay, so you want to deploy it in active standby fashion, but the problem is that this can only be deployed in one AZ, one availability zone. So that's one limitation. So you are paying for both firewalls, you're paying for the licensing for the both, and also the instance cost, but you are getting on the performance only from the one firewall, which is active at a time, right? Again, the configuration is also manual, right? But the good thing is that since they have this concept of TGW, you can attach this VPC, right? Yeah, this VPC here with this AWS TGW, and you get about 50 gig of throughput. That's what they claim. But again, you have to manually configure the route in the VPC table so that you can send the traffic towards this firewall, and then this firewall will send traffic back to VPC number 2, and then the return traffic should go through this firewall, which is in active standby case. Yeah, it's obvious, only one is active, so you don't have to do any SNAT or anything. But again, it's a complex process you have. Okay. Now I'm trying to find my pointer here, mouse pointer. Where did it go? Okay, I lost my, okay, got it. I think it happens when I try to annotate. Okay, so yeah, so that's one option. Okay, what about the second option? The second option is called the IPSec VPN model. So in this model, what happens that you see this TGW in the middle, right? Now you're not attaching this TGW with this VPC. You are building an IPSec tunnel towards this firewall. And why? Because now you want to run these firewalls in active mode. Okay, so if you want to run it in active mode, that means you want to use ECMP, equal cost multipath. That means you need to enable BGP, but since these guys are not directly connected, you have to build the IPsec to do all this, right? And even when you build the IPsec, the problem is that this IPsec is only going to give you 1.25 GB of throughput, right? This is what we also learned in the previous section. So effectively, what happens that you only get about 500 Mbps because the traffic will go to this firewall and come back in. So yeah, so even if you have purchased, let's say 6 GB license from Palo Alto, you're going to get about 500 to 600 Mbps throughput. And this is what I'm talking about when you are deploying firewall in just the basic plain mode. If you enable any advanced feature on this firewall, the throughput will even reduce further. Okay. So that's the thing. And then SourceNet, that's another big challenge. Why? Because since these guys are running in ECMP mode, and you want to make sure the traffic that hits the firewall is the firewall that is receiving the return traffic as well. So yeah, so a lot of challenges there. So we saw these problems in this space, and actually the vendors, they actually come to us. They said, we need your help to solve this problem, because we are in the business of the firewall, but not in the business of solving these type of challenges. So in a lot of cases, we actually see the firewall vendors are actually sending these customers to us to solve these challenges. Okay, so the way we do it, we basically deploy these firewalls into the transit VPC. So by now you are very familiar with this architecture, the transit architecture. That's your transit VPC. These are the icons for the Aviatrix transit gateways or spoke gateways. The firewalls are sitting next to them, right? And with this type of architecture, we can now give you the full performance of your firewalls. The management and operations is extremely simple, because now we are managing and programming all these routes, and routes in the gateway, route in the VPC, the routing in the firewall, routing in these gateways, spoke gateways, and also the spoke VPCs or VNET. Okay, so now you can deploy these firewalls without any compromise, with the full visibility and on operations in place. So when you look at this architecture, this is how it looks like. So you see a lot of black lines here, right? So you see these transit gateways here, and then you see spoke gateways sitting in two different AZs. They're running these lines, which are basically active mesh, right? Because all these gateways are active. Yeah, in the diagram, it looks like this, but in the controller, when you look at it, it's just one line between the VPC and transit VPC, right? So yeah, with this type of architecture, now we are eliminating all these issues or challenges that I showed you in the previous slide. And what you see here, that we make sure that these guys are highly available, right? And we give you the scale up and scale out option. So you can deploy, for example, 10 firewalls per AZ here. And if you want to scale up, like if you want to deploy higher throughput firewalls, you can actually scale up. That's not a problem. And since we have this controller that is looking at all the VPCs, VNets, transit gateways, the route table, and also the health of these firewalls, we can easily take these firewalls out from the operation if one goes down and bring it back in. And same goes with our gateways, obviously. So if the gateway, for example, goes down, the traffic will be automatically routed through the other gateway and will go to the destination firewall. And the throughput that we have is actually 70 gig, which is a lot. if you ask me, because remember the AWS TGW attachment will give you about 50 gig. We are actually going way beyond 50 gig, up to 70 gig. And I have this link posted on the QA panel, which talk about the performance and how we did this performance measurement. Okay, so I have not seen a single customer actually going beyond 70 gig so far. So yeah, it's there. It's applicable to all the enterprises out there. Okay, so let's take a look at this solution in AWS. So this is where, in this case, remember, this is the repeatable architecture. This is part of the MCNA by using all the Aviatrix component. But what about if a customer is saying, you know what, I want to use AWS TGW with the FireNet. Can you solve these problems for me? So the answer is yes. This is how we are solving it. So basically, when you are going to deploy this FireNet solution with AWS TGW, what you're gonna do, you're gonna attach this VPC, this transit VPC, to this AWS TGW, and then obviously these VPCs are attached to this TGW as well. And with the help of the programming and the secret sauce we have running in the background, we can automatically send the traffic to the firewall without needing to build any IPSec tunnel, without you configuring any SNAT. So basically you get the full performance out of this FireNet, right? So that's very important. And these firewalls you see there, they are actually deployed in different AZs. So there is a AZ level high availability as well. Okay, so no IPSec needed, no BGP requirement, no SNAT, full source IP address visibility. We maintain the session stickiness. We do the load balancing between these firewalls. And we also have some connection policies or a concept of security domain, which I'm going to show you, which allows you to actually create a policy. So instead of you saying that this VPC has a production workload and I need to send it to this firewall, no, you don't have to worry about that. You just go to the controller. There's a UI available. You specify this is the workload which I need, to be protected, and we'll take care of it, everything in the background. And not only that, but also the deployment of these firewalls can directly be done to the controller, right? So when you log into the controller, you see the UI, you can pick the Palo Alto version, and then we can also do the bootstrapping, and that's all good. But if you have a requirement to integrate the solution with the panorama, because obviously if you're running, more than 2, 3, 4, 5, or 10 firewalls, obviously in the majority of the cases, customers will have a panorama to manage that number of firewall. So we can easily integrate with panorama as well, and can manage this solution through panorama, not a problem. Now let's talk about the concept of security domain. Okay, so the concept of security domain is not only limited to the FireNet. Okay, even if you don't have a FireNet in picture, you can still use this concept with AWS TGW. So what you can basically do, you can create the policy and you can create the network segmentation or security segmentation for your different type of workload. So let's say you have production workload and some dev workload. And these production workloads are sitting in 3 different VPCs, right? The green VPCs you see here. Now with Aviatrix, what you can do, you can say, you know what? All these VPCs are running a production workload, and you can put them in one security domain called production domain in this example. And the rest you can put in the dev domain. And through the policy, you can say that the traffic from prod or dev is not allowed, right? So there will be no communication happening between these 2 domains. So that's what we can do with the security domain. And we can use this concept to provide the isolation and segmentation. And we can also use the same concept to insert the firewall into the flow or do the service chaining, okay? So this is how it looks like in the UI. So you log into the UI, you say, you know what, this is my production domain. All these VPCs are in the production domain. And if they are not connected to anything, that means nobody can talk to the production domain. Now, there is a case where you want this prod domain to talk to dev domain. So it's just a matter of dragging and dropping this dev domain here. And now once you have done that, now these guys can talk to each other. Okay. Okay, so life is good. Now your InfoSec team comes in and says, no, that's not what I want. Whenever you're talking to production domain, I want you to inspect that traffic with this firewall. So instead of you figuring out and then pulling your hairs, what you can do, you can just create this FireNet domain, right? Or that's how I call it here. And then you can say, oh yeah, you're done. You just move this FireNet domain here. And now what happens that any traffic that needs to go to this production domain here, right? It will automatically be inspected by this firewall. So this is how simple we are making it for our customers. Okay, so that was AWS. Let's talk about Azure native peering. So in Azure, we can achieve the same thing, right? Because this is the power of architecture. This is the power of Aviatrix Transit, that it is actually a replicated model across clouds. So same thing, same story. You have this VNET here. This is your FireNet VNET. And then you have this Palo Alto or any checkpoint or any firewall deployed here. So with this, with the same concept that I explained before, now you can achieve the same thing. Okay, but one thing you will notice that since we are not deploying our gateways here, right, you will not get any encryption. Yeah, so the firewall is there. It will be working. Your traffic is inspected, but no encryption. Same thing is over here in this case. When you're using AWS TGW and attaching your VPCs here, the traffic will not be encrypted between TGW and these VPCs. Okay, so you're saying, that's good. Now you showed me all these use cases, but you know what? My use case is very different. I have a single region and I have bunch of business units and they want their own set of firewalls, their own set of rules. And can you support that? So the answer is yes, definitely. So what you see here is an example where you have a central IT service and they are managing these firewalls and the VPCs are connected to this firewall and then you have the inspection done. So that's good. We achieved that. You saw this in the previous slide. But not only that, you can actually have more of these environments. So the business unit deployed as part of this architecture. So this business unit one says, I want to manage my own firewall and my own security policies because I don't want to be under this central IT services control. So okay, we can definitely support that, not a problem. Second environment comes in, okay, they have the same requirement, not a problem. Third, these guys are saying, I'm completely isolated. I want to manage my firewalls, but I'm isolated, so no problem, you can do that. So this is how you achieve this goal of connecting these different business units or different tenants, if you want to call them, with the same architecture, with the flexibility that they need, right? So this environment number 1, 2, they wanted the firewall and they want to be connected to the transit. Boom, done. This guy, number 4, does not need any firewall, but it still needs to connect to the firewall. Perfect, you can do that. It's part of the same transit. This guy is completely isolated for whatever reasons. And yes, we can definitely support this type of architecture. Okay. All right, so now this is how this picture looks like. This is an example where I have this on the left-hand side, the VPCs, the AWS. On the right-hand side, I have the VNET. Obviously, these are two different clouds. The transit is deployed here on the left-hand side, transit here on Azure. You are connecting these clouds with our transit networking, with the overlay, if you want to call it. And then you are providing the firewall services to your workload. And this is the model that we recommend to our customer. Why? Because you look at it, everything is encrypted. These multiple lines you see, these are all encrypted lines, right? But if a customer says, no, that's not what I want the native solution out there. So we discussed that already. Yes, we can also support native. solution with AWS TGW, no gateways in these VPCs, no gateways in the VNet, but you are achieving the same thing, but obviously it's not going to be encrypted traffic.